Alright, so starting off with point of inflection. So first of all, what is a point of inflection? If I represent it, it will be something like this. Or in this case, this would be the point of inflection. But if I were to define it, I would say it's the point at which the curve changes from sloping up to sloping down, or from sloping down to sloping up. Now, when exactly do we deal with point of inflection? So when the double derivative is equals to 0. In AS level, we learned that it was inconclusive. We cannot decide. But in A2 level, we are going to deal with what exactly do you do. That is, we deal with point of inflection in this case. We need to check whether the point of inflection exists. So when the double derivative is 0, it can result in either a maximum point or a minimum point, or a point of inflection, which you now need to consider since you are in A2, the second year of A levels. Hence, we need to apply the following steps. Find the differential and equate it to 0 to find the stationary point. Then find the double derivative and substitute the x coordinate of the stationary point and determine that it is 0. Then we need to check on both sides of the stationary point. That is, if the stationary point is 1, we will subtract 0.1 and we will check at 0.9, and we will also add 0.1 and also check at 1.1, that is immediately after the stationary point x coordinate. Once we do that, we are going to substitute in 0.9 as in the first example in the differential we found, and then after we add 0.1, we are going to substitute that 1.1 in dy over dx. That is our differential. Again, this is just an example that if the stationary point x coordinate is 1, you are going to check at 2 points, that is 0.9 and 1.1. Similarly, if it's, let's say, 10, you are going to check at 10.1 and 9.9. That is immediately after and before the stationary point's x coordinate. Then, if the answer of step 3, that is before the stationary point is positive, that is, the curve looks something like this. The gradient is 0 at the stationary point, and immediately after the stationary point it's negative. That means a maximum point exists. If the answer of step 3 is negative, that is, it slopes down, and then we have a stationary point, but the answer of step 4, that is immediately after the turning point, is positive. That means we have a minimum turning point. But what if step 3 and step 4 have the same signs? It means a point of inflection exists. Your curve may either look something like this, something like this, something like this, or something like this. Alright, so I'll recap. First of all, you need to find the differential and equate it to 0 in order to find the stationary point. Once you have the differential, you will differentiate the differential again, that is, find the double derivative and substitute the x coordinate of the stationary point and make sure that it is 0 and your stationary point is correct. Once you found the x coordinate, check immediately after and before the x coordinate and substitute those values in the differential so as to determine the sign of the derivatives. immediately before and after the turning point. Finally, if the signs are the same, it means a point of inflection exists. If the signs are not the same, you know that it's either a maximum point or a minimum point. But in this case, it's not so easy to determine the maximum point or the minimum point since, again, our double derivative was 0. So whenever you have a double derivative as 0, consider a point of inflection. So our first example, given the equation of the curve is this, and we are asked to determine the stationary point. So the first step is to find the derivative of the given equation. That is 3x squared 6x minus 6x plus 3 and equate it to 0. We will solve this quadratically or just simply break the middle term. And then factorize it. So we have 3x, x minus 1 and x minus 1. The factors turn out to be 3x minus 3 and x minus 1. Alright, so this is the x coordinate of the stationary point. You can go on to find the y coordinate of the stationary point too. That's gonna be this. And y turns out to be 6. So 1 comma 6 is our stationary point. So we found the x coordinate of the stationary point. Now we need to, and we found the stationary point. Now we need to find its nature. In order to determine the nature, we need to differentiate the differential by the sign the double derivative. So we have 6x minus 6. Substitute the x coordinate, that is 1, and subtract 6. So we have our double derivative as 0. Since our double derivative is 0, as expected, since in this lecture we're dealing with point of inflection, we need to deal with point of inflection. Again, whenever our double derivative is 0, we need to check for point of inflection. A few people write inflection like this, a few people write inflection like this. It's a mathematics exam, so you need not worry about the spelling. So, since we now need to check for point of inflection, the x coordinate of the stationary point was 1. Subtract 0.1 immediately before the x coordinate and add 0.1 immediately after the turning point. So you have 0.9 and 1.1. So just make a margin so your work is neat and tidy. So find the gradient at 0.9 and just a second. Yes. So dy over dx, yes. Then we had a minus 6x and we had a plus 3. Let me check if this is correct. Yes. Alright. 3x square minus 6x plus 3. And here we'll do a similar thing. And substitute 1.1. So the gradient here turns out to be So the gradient at 0.9 turns out to be 0.03, and the gradient at 1.1 turns out to be 0.032. And both these gradients are positive. You can check this for yourself. Finally, since the signs are the same, simply write for the examiner that a point of inflection exists. And this is where we wrap up point of inflection.